Hey guys, we are working on the constant rate of change. This is the third time I've had to make this video. It's not working out for me today. So our job today is to learn about the constant rate of change. Okay, so we have done something like this in class, okay, where all we have to do is figure out points. Okay, we have two variables, we figure out x and y, and then those are points on a graph. Okay, so I can put 0, 1, 2, 3, and then that helps me figure out the y. So if x is 0, I would just put 2 times 0 plus 4. 2 times 0 is 0 plus 4 is 4. Then I would try 1. 2 times 1 plus 4. That was my x. 1 right there. 2 times 1 is 2 plus 4 is 6. We just usually did it with a process column. This time we're not doing it with a process column. Then we have 2. So I would say 2 times 2 plus 4. 2 times 2 is 4 plus 4 is 8. Okay, so we've done this. Okay, our goal today is to find the constant rate of change, which is the number that will be in front of that x. Okay, so we always want to make sure that y is alone, which it should be in 7th grade. There's not a reason that it wouldn't be. So first of all, this is your basic form. Y equals mx plus b. I know that looks a lot like a lot of craziness to you, but the m on that last one was 2. And the plus b was, so the plus b was just that 4. B would be 4. Okay, so our job is to be able to put in m and b. Today our real focus is m, but I'm just going to show you the whole thing. So the variable for constant rate of change is n. Remember we said the number in front of the x. Okay, how do we find that? Well, we find that through delta y over delta x, delta y being change in y. That's it. And delta x is change in x. Okay, that's it. So delta is change. So our job, really all it is determine whether these have a constant rate of change and figure out what it is. But we're just going to do the whole thing, and I'll explain that in a minute. So delta y over delta x, remember this is m. I will let you know, sometimes it will be k. If we have a proportional situation, which means it also has to go through 0, 0, then it would be k. But right now, again, we're focused on m. Okay? So, delta y. This is what we do to find delta y. Change in y. Why? Because y is on the bottom. Okay? So I have to figure out how are these numbers changing by. Oh, by the way, make that a 16. Everybody, stop and make that a 16. Okay? So 7 plus what is 10? Hopefully you know that's 3. 10 plus what is 13? And 13 plus what is 16? That would be 3. Each of these would be 3. Okay? This 3, even though it's down, because y is down, I put it on top because delta y goes on top. Okay? So then we need to do the same thing here. Well, if you look at 2, 4, 6, 8, how are those skip counting? And hopefully you can tell those are skip counting by 2. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. So the change in x actually goes down. Okay? So this is m. That means we have a constant rate of change of 3 over 2. Okay? So this is where the 3 over 2 would be right there. Okay? So I'm going to write this here. Y equals mx plus b. When you write an equation in this form, we call it slope-intercept, okay? Then the m goes right here. We got 3 over 2. The change in x is 2. It goes here. Okay. Now what I don't know is b. I don't know if this is a proportional situation. If it is, then this is also the letter k. It would be m and k, the constant rate of change and the constant of proportionality. So all I have to do is figure out if this goes through 0, 0. 8, 6, 4, 2. If I follow this backwards, subtracting 2 each time, I would get 0. Now, if I follow this pattern, I'm subtracting 3 each time. So 7 minus 3, I would get 4. Okay? So this is not 0, 0. So this is not proportional. It is not K this time. Okay? It's not K. But I do now have B. Since it didn't go through 0, 0, it went through 4. Guys, that's where it crosses the y-axis, which is why we call this our y-intercept. So y'all just actually wrote an equation. Super easy. Delta y over delta x, and then take that table back to 0. Okay? Now, we're going to do number 2. So let's try number 2. Delta y over delta x. Okay? So, how much are these changing by from here to here? Hopefully you know that's 1. 0 plus 1 is 1. 1 plus 3 would give me 4, and 4 plus 5. Guys, this is the change. That looks kind of strange, right? Last time it was all the same. That normally would tell me, like, I don't think I have a constant rate of change, but I'm not going to go with that yet. I have to take it a little further. Okay, so my delta x, well, these are all changing by the same rate. I'm just counting by ones here. Each time it's increasing by 1. Well, when I simplify these fractions, this is equal to 1, this is equal to 3, and this is equal to 5. That means all of those are different. So there is no constant rate of change. There's no constant rate of change here. That means, guys, we don't have to go any further with it, okay? If there's no constant rate of change, it won't be linear. A constant rate of change means that we have a linear situation. Okay, even though it went through 0, 0, doesn't mean it's proportional because there was no constant rate of change. Two things have to be true for you to have that proportional situation. Okay, so on this one, delta y over delta x. So really quickly, I'm going to give you a hint. It's going to be the same thing for each one. How much is it between each of these? I'm going to just wait for a second. How much is it between each of these? And hopefully you can tell it would be 15. If I don't know that, 45 minus 30 is 15. 60 minus 45 is 15. 75 minus 60 is 15. So my delta y is 15. And hopefully we can tell all of these are just increasing each time by 1. So even though the x is on top, I still put delta x on bottom. So that means my m is 15 over 1. I can leave it as 15 over 1 or put just 15. It doesn't matter. Okay, but I do know my constant rate of change, my m, is 15. Okay, my m is 15. So, y equals mx plus b, right? We did this before. Y stays the same, x stays the same, and we already found 15. Now my job is just, real quickly, I'm going to determine if this is also proportional. If it's proportional, then this is also k. Okay, so to determine if it's proportional, I just take this table back. 4, 3, 2, 1, 0. And then each of these goes down by 15. So what is 30 minus 15? And hopefully you know that's 15. Okay, 30 minus 15 is 15. So is this proportional? No, this is not proportional. It does not go through 0, 0. It doesn't. Okay, so it goes through what? 0, 15. That is my B. The number, even though it's the same, it's fine. That just means it crosses the y-axis at 15. Okay? So here's my equation. Okay? Okay. Number 4. Delta y over delta x. How much is between each of those. And if you're counting up or subtracting backwards, you should get 7. 28 minus 21 is 7. 35 minus 28 is 7. 42 minus 35 is 7. Or I can count forward. This is my change in y. Change in y goes on top. It's opposite of how you see it in this horizontal table. Now what about this? Okay. Each of these skips by what? By 2, right? So 2 goes on bottom. So our constant rate of change is 7 over 2. That is our m. Okay. Now this one's going to be a little more confusing. Okay. Some of you are going to get it. Some of you may struggle here. We already know this. We already know this is 7 over 2, right? What I don't know is if this is proportional. I only need to go back 1, okay? Not 2. So I only need to go back half of the distance that I've been going. Each time I'm going back by 2, I only need to go back by 1. That means I need to go half this distance back. So if you take half that distance, well, that would be 3.5 or 3.5, okay? If I only go back 1, if I go back 2, I go back 7, okay? If I only go back 1, I'm going back half this distance. So 21 minus 3.5, and I would not expect you to do this. I would not give you a problem like this in the 7th grade, but a few of you may catch on here. So that would be 5, that would be 7, that would be 17.5, okay? Which, if nothing else, hopefully you could tell immediately that it wasn't proportional. So if the question was just, is it proportional? Without doing the math, you should be able to tell it is not proportional, okay? So you have 17.5 and 0. So this is not K. This is not proportional. So my B would be 17.5. That's a little bit of an upper level problem there, okay? Okay, now the last one gives us a table, okay? So, but what we can tell is it is proportional, okay? So not only is this M, it's also going to be K, okay? Now, we can do this a couple of different ways. I'm going to just show you. We can do something called rise over run, where we count it. So rise over run would just mean point to point. So starting here, point to point. How much do I rise? Well, to get there, it looks like it's 24. And then I run over, up and over, so that would be 2, which simplifies to 12 over 1. I could do it from here, from 24 to 48, that's 24 that I'm rising. 24 plus 24 gets me to 48. And then from 2 to 4, that's 2. Okay? So it's 24 over 2, so, or 12 over 1. Now, let's say you're not following this right now. What you can do is just make your own little mini table, okay? This point is 0, 0. This point is 2, 24. I could use this point, 4 and 48. Okay, and then I would just do delta y. And guys, this will just be 24. So delta y would be 24. Delta x would be 2. And this is an example of one where we would simplify it. Because these are both, I can do just 24 divided by 2. Or divide the top and bottom by 2, it doesn't matter. But I get 12 or 12 over 1. So m is 12 over 1. So my constant rate of change is 12. And it says let's put the units. So 12 dollars